to continue now with and talk about radicals. Radicals, that's my page 5. Radicals. What are they? Why do we need them? Etc., etc. So I'm sure you're familiar with the square root. There is a 2 in here, but we do not write it. So that is what it's called, the index. But it's 2 because the square root. This is the radical symbol. And what's in here is called radicand. So there are many different types of square roots. However, they are classified into 2 categories. A root with an even index and a root with an odd index. So what's a big deal here? It's a big deal because underneath here, underneath a root with an odd index, for example, underneath the cube root, underneath the fifth root, I can have anything. Positive numbers, 0, and negative. So this is what I like to call friendly. I don't need to worry about it. No worries. Anything goes. So here's an example. If I want to determine the cube root of 8, I get a number. And the number is 2. Why? Because 2 raised to the index, raised to the third power, is 8. Since 2 raised to the third power is 8. Let's say the fifth root of negative 32. I know that this is negative 2. Why? Because negative 2 raised to the fifth power is negative 32. Sorry, there's not enough room there. Because negative 2 to the fifth power is negative 32. That's the reason why. So notice that under any index that is odd, I can have anything, including 0. Let's say the 7th root of 0 is 0. Why? Because 0 raised to the 7th power is 0. So never be afraid of a radical with an index that is an odd number. The smallest is 3. There is no index 1 or negative. Okay, so the index is 3, that is odd, 3, 5, 7, and so on and so forth. Can I calculate any of this with a graphing calculator? Yes, I can. So, for example, one option is under math, we have item number 5, we have item number 4, which is just a cube root, but we also have the general situation. I have to enter the index first and then use the symbol number 5 and then put whatever. So I am going to write the index, in our case was 5. I am going to copy, I never use this situation. I'll show you how I do it, which I think it's much easier. So you put the index, you select under math, you select number 5, which is any index, but you already entered it. And then inside the radical, or the radicand, is negative 32. Put parentheses. Depending on calculators, it may or may not work without. But to be on the safe side, I always put parentheses. And the answer has to be negative 2, because negative 2 raised to the fifth power is negative 32. Now, all radicals can be presented as exponents. So when I have the cube root of 3, I can rewrite it as 3. Let me put something else here, like 2. So the cube root of 3 squared can be written as 3, and the power is a fraction. The fraction is always formed in the following way. The exponent is the numerator. The index is always the denominator. So if I have in general, let's say, the mth, my m has 3 bubbles, root of x to the nth power, this is a radical. It can be rewritten as an exponent or exponential notation. But please remember, the exponent has to be a fraction. And the fraction is n over m. N over m. This is the numerator, and this is the denominator. So any radical, no matter how beautiful or not is, it can always be presented as a exponential notation with the exponent that is a fraction. Example, let's say the cube root of x is x to 1 over 3. The fifth root of a squared is a to 2 over 5. This is how I perform my calculations. So this is my preference. You can use what you like. So in this case, I would have not used the math and la la la. I would have put in parentheses negative 32, and I would have raised it to power 1/5 in parentheses 1/5. This is easier for me than clicking here and selecting and putting the index first, la la la. That's my preference. You don't have to use my method. I always prefer to put the fraction, and the answer has to be negative 2. Now, let's talk a little bit about even indices. So here, friendly, everything goes, no problem. But let's talk about this situation. This is not a friendly situation for the most part, because underneath the square root or fourth root or sixth root, it is mandatory to have only positive or 0. I cannot have negative. What happens if I have negative? I'll show you. But the requirement is under an even index, radical with an even index, all numbers have to be positive or 0. So if you ask me, okay, if you have the square root of x, what condition does x have to fulfill? Fine, I will say, I know. X must be greater than or equal to 0 because the index is even. But if you say, tell me the condition of x if x is under a cube root, I'll say no. There is nothing. X can be anything. But if the index is 2, or if it's 4, or if it's 6, I have to worry about it. So the quantity under the square root, fourth root, etc. has to be greater than or equal to 0. So looking at our examples here, they're already talking about domain. It's the same thing. We're going to talk in detail about domains in general. But for this function, the domain is, since the index is even, the domain is greater than or equal to 0. And they may give it to us in an interval notation. 0 is included to infinity. Wrong, 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 wrong. This one does not include 0, so it's wrong. This one includes negative numbers. No. So let's look. So if I have the square root, here's the square root, and I put in parentheses negative 2, the calculator will scream at me. It will say you lost your mind. Because either a square root, fourth root, yada yada, any even index, I cannot put a negative number. So coming back, are you gonna, is this going to kick me out again? Okay, so I have to select 0 to infinity. So in interval notation, so we can write it here. I either write this, which is perfect, but if they want us to write it in interval notation, you have to write bracket 0, infinity. Both are correct, but you have to select among what they give us. Any questions? Any questions, please? Fill in the blank so that the resulting statement is true. So they tell us the fifth root of negative 243 is negative 3 because what should I have here? The fifth root of negative 243 is negative 3 because, can anyone help?
Would it be negative 3 to the fifth equals negative
Absolutely,
43?
absolutely. So then which one do I select?
The last one.
Exactly, exactly. Perfect. So we can check so it doesn't scream at me that I missed it. Okay, so, oh, I forgot. I didn't want to click on next. So the domain means what values can x be replaced by. And this is a cube root. What will you select? For the cube root or fifth root, what will you select?
The first one.
Yes, absolutely. No restrictions, friendly. Friendly, I don't have to worry about anything. I can sleep tight. Determine whether the statement is true or false. The square root of negative 36 is a real number. The square root of negative 36 is a real number. What do you think?
False.
Exactly. Exactly. This is how I showed what I showed you here, some square root of a negative number. No, it's a non-real number. It's not a real number. So this is false. If it were the square root of 36, yes, I would have said 6. But the square root of negative 36 is not a real number. The cube root of negative 36 is, but not the square root. Okay, moving on. Explain why is not a real number. Excellent. So, when we solve the equation x squared minus 1 equals 0, and we solve something similar tonight even, what will you tell me to do?
Add 1.
No, because I want to factor this, right? I want to use this. That's okay. That's okay. I want to use the zero product principle. So what do I have on the left?
X plus 1, X minus 1.
Very good. And then we get the two solutions. We discussed that, negative 1 from here and 1 from here. Perfect. But here's what happened. Many years ago, this is nice and easy. They said, how do we solve this? What do I do with this? It turns out that this is a positive number plus another positive number. This will never be 0. So if you add 2 apples to an apple, you can never get 0. If we add 4, because x squared is always positive, no matter what you do. If you raise 2 to the second power or negative 2 to the second power, you still get a positive number. A positive number plus another positive number can never be 0. So they said, oh, yeah, well, in that case, we have answers, but they're not real. So what they did, and we're going to talk about this principle very soon, they moved indeed because they couldn't factor this. So this time they said, okay, we have to find a different way. They moved 1 to the other side, and they said, this is not possible. How can a positive number equal a negative number? So their answer was no real number solutions. So it must be something else. So they took the square root. Remember, it's quadratic. It still has 2 solutions because the power is 2, the degree is 2. So there must be 2 solutions. So they said, okay, then x equals plus or minus the square root of -1. But I just said that this is not a real number. Not possible. So they said it's not a real number. We are going to call it I, lowercase I, the imaginary unit. The imaginary unit. So then we said x squared plus 1 equals 0 has 2 solutions, but they're not real. Not real. What are they? Imaginary. And the solutions are plus or minus I. That's how I, or the imaginary unit, was born. Because there was a need to solve this equation. And they said, okay, fine. A real number does not solve this equation, but maybe some other type of number will. And they came up with this little I. And they said, this little I will solve that equation, plus or minus I. So then it means that I squared equals -1. I squared equals -1. So please remember these two. This is number 1, and this is number 2. That x squared plus 1 equals 0 has the solutions plus or minus I. And something unheard of, I squared equals -1. But this is okay because I is not a real number.